Question 8. Work out an estimate for the value of the square root of 63.5 multiplied by 101.7. Well, estimate means to round. As I'm taking the square root at the end, therefore I'm going to round each of my numbers to the nearest square number. Well, 63.5, nearest square number to 63.5, in this case is 64. Leave the multiplication sign alone. The nearest square number to 101.7, in this case would be 100. When taking the square root, I can separate this as being the square root of 64 multiplied by the square root of 100. The square root of 64 is 8, as 8 times 8 gives us 64. And the square root of 100 is 10, as 10 times 10 is 100. And 8 times 10 gives us 80. 2.3 in brackets to the power 6 is 148, correct to three distinct figures. Find the value of 0.23 in brackets to the power 6, correct to three distinct figures. If I compare what I want to what I have, as I want 0.23 and I have 2.3, I can write 0.23 in terms of 2.3 as being 2.3 over 10, as 2.3 over 10 is 0.23, and I want it raised to the power 6. If you have a fraction raised to the power, we can separate this as raising the top to the power 6 and the bottom to the power 6. So therefore I can have 2.3 in brackets to the power 6 on the top, and I can have 10 to the power 6 on the bottom. I know that 2.3 to the power 6 is 148. That was given in the question. I should know that 10 to the power 6 is just 1 followed by 6 zeros, i.e. 1 million. And 148 divided by 1 million will be 0.000148. Part C. Find the value of 5 to the power negative 2. Whenever you see a negative power means the reciprocal. In other words, to turn it upside down. If it's not already a fraction, we know 5 is the same as 5 over 1. Hence, turning upside down, whatever's in the top will go to the bottom, and vice versa. Hence, I'm going to rewrite my fraction as being 1 over 5, and we always write the power positive, so 1 over 5 squared. And on the bottom, 5 squared, we know means 5 multiplied by itself, and 5 times 5 gives us 25. So my final answer is 1 over 25. Question 9. Work out 3.5 multiplied by 1 3/5. Give your answer as a mixed number in its simplest form. When multiplying mixed numbers, our first step is to convert any mixed numbers to top-heavy improper fractions. To do this, we always keep the denominator the same, in this case 2. We always multiply to the side and always add number on the top. 2 times 3 is 6, and 6 add 1 gives us 7. Leave the multiplication sign alone. Again, converting our mixed number into a top-heavy improper fraction. Keep the denominator the same, in this case 5. We always multiply to the side and always add number on the top. Here, 5 times 1 is 5, and 5 over 3 gives us 8. When multiplying fractions, we just simply multiply the tops and multiply the bottom separately. On the top, 7 times 8 gives us 56, and the bottom 2 times 5 gives us 10. We know that 10 divided into 56, 5 whole times, as 10 times 5 is 50. As we had 56, the remainder is 6, and the remainder is always over the same denominator, so in this case 6 over 10. Leaving the whole number alone, in this case 5, we can simplify our fraction apart, as we can see both top and bottom are divisible by 2. So dividing top and bottom by 2, on the top 6 divided by 2 gives us 3, and the bottom 10 divided by 2 gives us 5. Question 10. Using the graphs, find estimates of the solutions of the simultaneous equations 3y plus 2x equals a half and 2y minus 3x equals negative 113 over 12. As we're using the graphs, we're using no algebra, hence why they're estimates. We should know the solution for two simultaneous equations as they're both lines. It's the point where the two lines intersect. As these are our two lines, we consider intersect this point here. Hence, x is equal to 2.3 and y is equal to negative 1.3. Question 11. A bus company record the ages in years of the people on coach A and the people on coach B. Here are the ages of the 23 people on coach A. Complete the table below to show the information about the ages of the people on coach A. To find the median, our first step is to ensure our list is in order. In this case, as it's already in order from smallest to largest, to find the median, I can simply cross off the smallest on the left-hand side with the largest on the right-hand side. And I can just repeat this process. As I have an odd number of values, I have 23. Therefore, I'm going to be left with only one value in the middle, which is our median. Here, our median age is 59. To find our lower quartile, I only look at the ages less than the median. And again, I cross off the smallest with the largest. And I repeat this process until I'm left with only one value in the middle, which is our lower quartile. In this case, our lower quartile is 53. To find our upper quartile, I only look at numbers greater than the median. And I'm going to cross off the smallest with the largest. And I'm going to repeat this process until I'm left with only one value in the middle, which will be our upper quartile. Here our upper quartile is 66. We are now given some information about the ages on coach B. Richard says that the people on coach A are younger than the people on coach B. Is Richard correct? You must give a reason for your answer. Well, if we look at the medians, the median age on coach A is 59, whereas the median age on coach B is 70. So in this case, yes, Richard is correct, as the median age on coach A is less than the median age on coach B, as 59 is less than 70. Question 12. Here are three spheres. The volume of sphere Q is 50% more than the volume of sphere P. The volume of sphere R is 50% more than the volume of sphere Q. Find the volume of sphere P as a fraction of the volume of sphere R. As I'm not given the volume of any of the three spheres, therefore I'm going to start by assigning an arbitrary value for the volume of sphere P. I'm going to use the number 100. As I know sphere Q is 50% more, as this one's 50% more than sphere P, as I've called the volume here for 100, therefore 50% more would be I could either times by a multiplier of 1.5, or work out half 100 is 50 and add it on. Therefore, the volume of sphere Q will be 150. I'm told sphere R is 50% more than the volume of sphere Q. So if sphere Q has a volume now of 150, or 50% more, again, if using a multiplier, I could times by 1.5, or 50%, half it, half of 150 is 75, and 150 and 75 will give us the volume of sphere R to be 225. As we were asked to find the volume of sphere P as a fraction of the volume of sphere R, well, the volume of sphere P I assigned to be the number 100. Fraction means divide, so divide it by the volume of sphere R. Well, sphere R has a volume of 225. So I can simplify my fraction by dividing top and bottom by 25. 100 divided by 25 gives us 4. And 225 divided by 25 gives us 9. Question 13. Given that n can be any integer such that n is greater than 1, prove that n squared minus n is never an odd number. Well, first of all, I can realise that n squared minus n, they both have a common factor in n, so I can factorise out single n. What do I times n to get back to n squared? We're missing n. And what do I times n to get back to negative n? As I've already got the n outside, I know if there's no number in front of the letter, a number is 1. So negative n, number outside is negative 1. So therefore, n times what gives us back to negative 1n? I'm missing negative 1. As we're told n can be any integer, we know an integer can only be either even or odd. Therefore, if n is even, then n minus 1 is odd. Because if n is even, any even number, subtract 1, will always give us an odd number. The other option is if n is odd to start with. And if n is odd, therefore we know n minus 1 is even. Because if n is odd, an odd number, subtract 1, will always give us an even number. Hence, substituting into our expression, we know outside a single bracket, it means to multiply. So if n is even and n minus 1 is odd, therefore we know an even number multiplied by an odd number will always give us an even number, because even times anything will always give us an even number. And if n is odd, odd times n minus 1 is even. And the other option is an odd multiplied by an even number, again, will always be even. Question 14. Find the exact value of tan 30 multiplied by sine 60. Give your answer in its simplest form. Well, you should know that tan 30 is an exact value, and that comes out to be 1 over root 3. Multiplied by, we know sine 60 gives an exact value of root 3 over 2. We're multiplying fractions. We just multiply the tops and multiply the bottoms separately. Well, 1 times root 3 in the top will simply give us just root 3. And the bottom, root 3 times 2, will give us simply 2 root 3. As we're asked to give our answer in simplest form, I can divide top and bottom by root 3. On the top, root 3 over root 3 will cancel to give us just 1. And the bottom, 2 root 3 divided by root 3. The root 3's will cancel to leave us just with 2. Question 15. The diagram